Okay. No self introduction for the afternoon. No need. Okay. And maybe 我还是
不是你这个是没事啊，有，我知道。
没有关系，就是maybe I have to give you official self introduction, right? I was born in 1996, and I graduated from North China Electric Power University, 2021. 2021, and now I am in the school for 5 years now. My major is of course I teach multiple lessons. One of this is distribution automation. And before that I teach PLC. And currently, I do not teach. I get another position. Now I'm working in the department for the skill level qualification. In China, we have a 8th grade system for the skill level. Apprentice, primary worker, intermediate worker, senior worker, technician, senior technician, master technician, and chief technician. 8th grade. My job is to organize the qualification exams for these 8th grade. So not just the distribution automation, but I have taught this for 2 years and half a year of field experience. Half a year of field experience. You know, field experience means you don't stay in the classroom. You go to the company. You go to the local state-grade company to learn about the operation and the maintenance of distribution automation. Okay. And my partner, you already know, Miss Tan and Mrs. Wu.
Wu? That is my
Pronounce like
Wu. I am sorry someone that my nickname is Wu.
Okay. Continue. First, I would like to deliver this lecture in three parts. The background development of China, of distribution network in China, and the system composition, and the experiment demonstration. We already know in China we divided the power system into 5 elements, right? The 5 elements: generation, transformation, transmission, distribution, and consumption, right? Usually in China we recognize the voltage level below 110 kilovolts as distribution. 110 kilo below distribution. Okay. So is in the transmission network is quite mature now, but the infrastructure is enhanced from time to time. Like we know we have what UHV, right? UHV, ultra high voltage transmission, right?
Ultra high
And
voltage.
and something like HVDC, high voltage DC transmission, DC transmission, right? Okay. In China, we have strict criteria or quota to measure the quality of power supply. One of these is reliability. We call it 4 nines. 4 nines. What is 4 nines? Means the reliability of power supply is above 99.99%. Okay. How to calculate the reliability is to
1 minus
subtract the annual average outage time, divide by the year of what? By the time of the year, right? The time of the year is we know a year have 8,760 hours, right? Then plus then what will we do?
times 100%.
Yes. 100%. Then we can get the figure of the what? Of the power reliability. This you can see is a quite strict, quite restricted, quite hard criteria to meet. But we did it. I don't know whether it is what is your average outage time in Rwanda?
I don't know.
When I was teenager, or maybe we can say 20 years ago. 20 years ago, everybody in our country have to prepare some candlelight in the house, just in case the power goes off. That's 20 years ago. That's 20 years ago. We will prepare candlelight in the house. But now we usually don't need that. You cannot feel the maintenance or the operation of a power system because it doesn't go off. Because the feelingness of the operation of a power system. Okay, and as the loads and the demand goes bigger and bigger, we can name countless facilities or utilities that have to use electricity to drive, right? Like basically lights, and we should say what, and air conditioning, right? And smartphone chargers, right? And nowadays we also have EVs, right? EVs as loads. Okay. You know? 我不来了，我没看你机器。
是。不是，我有点没有想，没有准备，你是这么讲的吗？
特别是
你讲啊。
哎呀，我的个疯了！
提高供电可靠性的方式。
这样准备的，行吧？
下次我要记得你们讲的是
OK。What can you imagine about, what can you name about the method of improving the reliability of a distribution network? Trees, right? But we can connect the ends of different lines together, making a loop, right? That's enhance the stability of a network, right? Okay. Here we listed some of the methods that can implement can be implemented in the method that we can improve the reliability of the distribution network. Okay. Now today we are focusing on the distribution automation. Okay. This screen is not very friendly to me. OK， 就是这吧，就是这个。
商业比较
就是这个。哦，这是商业。
你往前。
是这样，这下一步。那 OK， 好。Distribution automation. Why do we need that? We know this. You know this figure.
Transformer.
Primary, secondary, and in the secondary we go outgoing lines, right? We have outgoing lines, and outgoing lines we equip with current breaker, right? We have current breakers, okay? And if fault occurs, right? If fault occurs, then the circuit breaker can and then cut off the whole line, which means power off, right? Which means power off. But if we extend the relay protections into the distribution network, like we're just not simply have one circuit breaker. We have multiple circuit breakers. We can what? Zoom in. We can eliminate. We are joined by others. Fellowship. Where was I? If we can put more circuit breaker in the outgoing lines and divide the distribution line to
several parts, we can eliminate, we can smaller the fault area, right? We can make the fault area smaller, right? Okay. And what is the difference in the engineering? What is the difference? What is the challenging of this? You know, this is one outgoing line, right? This is one outgoing line. I simply put just one main string of this, right? But usually it has some branches, right? Some branches. And if we really want to realize the enhancement of the reliability of a distribution network, we have to put circuit breaker on the branches, right? On the branches. So, what is the major challenge or the problem when it occurs when we want to extend the relay protection into the distribution? What is the major challenge in the implement? What is the challenge?
I think the major challenge is to realize where the fault is occur and to identify.
You mean to recognize different kinds of faults?
Yes.
Good, well said, well said. But I should say that the fault that can occur in the distribution network is the numbers of faults that can occur in the distribution network is much less than the fault that might occur in the transmission system. Is that so? Okay, do you agree with me? Do you agree with me? When the voltage level is lower, the numbers of the kinds of faults that might occur in the distribution network is less. Is that so? Do you agree with me? Do you agree with me? When the voltage level goes higher, the more complicated the situation might occur. Is that so? Yeah, but in lower voltage, it is much simple. Do you agree?
Yeah.
Yes. So your what you have said might not be the most the challenges thing in this. Okay. So as I say, what might be the most challenging thing for us to implement the relay protections from substations into the distribution line? What challenges might we make? Stations, we have more than one transformer, right? More than one transformer and multiple outgoing lines, but they all are integrated in one area, right? Right. But when this outgoing line stretching into the distribution network, where could it be? It could be anywhere. On a wooden bond, right? Okay. You can turn around and see that equipment. See the equipment. Turn around. See that equipment. Okay. Turn around. Circuit breaker on the column. Circuit breaker on the column, right?
circuit breaker on a column facing more challenging environment than the circuit breaker in a substation. Do you agree? Do you agree? And if we have to stretch, or we can say stretch the function of relay protection from substation into the distribution line, we have to place several column circuit breaker on one outgoing line in distribution network, right? So that means what? That means the numbers of equipment going more and more, right? Going more and more. That's one challenging. And secondly, you know, in relay protection, we have multiple methods to achieve relay protection, right? The most common one is the most common type of relay protection is overcurrent relay protection, right? Overcurrent relay protection. Engineeringly, how do we achieve overcurrent relay protection? The first step is what? What is the first step engineeringly to achieve overcurrent relay protection? What is the first step? Let me repeat my question. What is the first step engineeringly to achieve overcurrent protection?
To reduce the overcurrent. Or to reduce the overcurrent.
Reduce? No. Not is not the point. I mean is, how do you achieve overcurrent protection engineeringly?
To achieve the
And current transformer, it alone cannot achieve relay protection. We need what? We need usually we have this equation, right? Set current, right? Setting current, right? We should compare the fault current with the setting current. Setting current then is larger, then it breaks off. Right? This is the equation. But in engineering, we have to compare it in the digital way, right? In the digital way, and then secondly, we now measures the current. But if we have to realize automation, okay, we measure the current. Who knows the current now? After we measured the current, who have the current now? CT, right? The current transformer knows the current locally, but we do